right, guys, here we go. 1-3 today. Okay, our goal today is to use end behavior, our zeros, and what we call multiplicity. That's something a little bit new to you guys is multiplicity. Okay, to go ahead and graph a sketch. Just a sketch, not exactly what it looks like. We're only sketching it using the information we have to get a sketch of what it looks like. Make sense? Okay, really quickly, will you hand me a 1-3 out of there? Or do I have it right here? Never mind, it's right here. I just want to make sure I'm covering everything. All right. So, let's factor this really quick. Okay, quickly factor him. You be able to see it like that. It's something we'll learn about. Or what's the factor before that makes it -4? 2 and 2, right? You agree with me on that? 2 and 2. If he's ever a leading coefficient, I really don't have to do a factor by grouping. I can just squeeze over to the 1. I can just say, oh, that's x minus 2, x minus 2. You guys agree with me on that? Any questions there? Okay, so this is the exact same thing as above. You guys agree? Okay, what is our zeros of this polynomial? What makes this graph 0? I plug a 0 in for that. Take the square root. Okay, x equals 2. I only have 1 0, but how many zeros should I have if it's x squared? 2, and it technically does. Remember, it has the same 0 twice, correct? We call that a multiplicity. If you're using the same 0 multiple times, okay, that is a multiplicity. And we can tell that by the degree or the power on that 0. That tells us, oh, I'm using this 0 twice. It's x minus 2 times x minus 2. Does that make sense? Any questions there? Yes, sir. 3 times, so we'd have a multiplicity of 3. Okay, you guys understand when I ask what a multiplicity is? It's after you have factored it, each individual 0 has its very own multiplicity. Okay? That multiplicity can tell us what to do, and I'm going to explain that in just 1 second. So that multiplicity can tell us what to do at that specific point. And we're kind of going to look at it using the things we've already known. Okay? All right. So, once again, on the graph, x minus 2 . What does x minus 2 squared look like as a graph? Remember, this is x squared. What does x minus 2 look like? Remember, we just shifted to the right 2. Which one? You guys remember doing that from last year? And it should make sense that we're right 2 because that's where our 0 is. Okay. Now, let's start at the very beginning. Our equation was x squared minus 4x plus 4. What's the degree? 2. The end behavior of something x squared with a leading coefficient that is positive should be, as x goes to negative infinity, it's going up to infinity. As x goes to positive infinity, it should be going up to infinity, correct? Do we have that? Okay. Notice we have one turning point because it's x squared. It should have one turning point, correct? Okay. Now, as I look here, it bounced, right? Does that make sense to everybody? What bounced means? Notice when I hit that 0, he went right back up to me. Okay? Something you might want to write down is if it's an even multiplicity, it is going to bounce at that 0. Let's see what an odd multiplicity would do. Okay, so this is f of x equaling x minus 1 cubed. What is our zero of this function? Where will we be zero at? 1. Okay, first off, here's what a cube looks like, right? Everybody there with me? The basic cube. Now we can get different other cubes by the graph itself, by what x squared, all the x's as well. Okay, but this graph right here is this. What happened when I had an odd multiplicity at that point? Notice did it bounce? What happened? It went through it, or we call it crossing. So odd multiplicities bounce, not bounce, crap, son of a monkey, cross at the zero. Okay, I'm going to show you how we're going to go ahead and graph it. Yes, Ethan. Ethan or Nate? It was Ethan. You did say. Okay, go ahead. At that point. Yep. No. Because that's, notice, okay, let's look at this guy. Remember, this graph right here was just x cubed, correct? Just the basic parent function x cubed. What value makes him 0? 0 and 0. Okay. Now, what I'd like you guys to think about is we're going to graph something very quickly. We're going to graph it, not use our calculator. We're going to do a step. No, it has root beer barrel. That's a devastating thing. Okay. How many zeros is this equation have? Okay, somebody said 5, who said 5? Awesome. There's technically 5 zeros. Let's get to that. All the x's notice. This guy actually has 2 of them, this guy has 1 of them, and this guy has 2, so the total 5. Technically, that's our degree. Okay? This is x to the 5th. Everybody with me? If I distribute this through, this would get x to the 5th. Everybody understand how I can get that? Because notice, I'll take this x squared into him, right? This will become an x squared, so this will be x squared, I'll take that x2 into x squared, which comes out to be x to the 5th. Does everybody understand that? Great. How many zeros do we have as in terms of number 1? We do have 5 zeros, that is correct. But we have what value makes this value? 0. What value makes this guy 0? 4. 6. All right. So those are the values of my zeros. But like you said, I do still have 5 zeros, right, Tim? Okay. That is a correct statement. Does everybody understand, first off, where he got the 5? Because that is important. Just looking at all of the multiplicities and adding them together. Right? Good? Okay. So here we know on this graph, we don't know what it looks like, but we know it's going to be a 0 here, a 0 here, and a 0 here. Do you guys agree with that? Because those are the places where that graph would be 0. Okay, now like I said, we're going to need to know our zeros, our multiplicities, and our end behavior. Okay? Like he brought up, this is going to be an x to the 5th. Okay? x to the fifth. So what end behavior do we have? We have this type, don't we? Now, we got to ask ourselves, what would be the leading coefficient, though? Would it be positive or negative? If I distributed this through, would it be a positive or a negative leading coefficient? It would be positive, because this guy's already positive. When I put it through, that's the x cubed. Then when I take that x cubed, I take it into the x squared, which becomes positive, right? So it would look like that. Everybody there with me? Okay, so I'm going to graph my end behavior first. Like I told you guys, we know this is always the same for any x to the fifth with a leading coefficient, as this. Remember, the body of the graph might be different, right? Remember how we talked about that. But we do know that it will go as, I don't have any more zeros, so I do know from there on out, I have to be going to infinity because of my end behavior. Over here, what does it have to do? It has to go down. How do I know it's not crossing over or touching over here, crossing over here? If there's no other zero. So I know it has to first cross here, or bounce, I don't know yet, and cross or bounce here at the end, correct? Does that make sense? I'm trying to get at there. Making sense in my head, but hopefully it's making sense for you guys, because I already know how to do it. Okay, what is the multiplicity of this first zero? It's even. It's a 2. So therefore, as you said, it's even. And as we just wrote down, anytime we have an even multiplicity, we should be doing what? Bouncing. Now, do I care how accurate you are on these graphs? No. All I care about is, are you using the zeros? Are you using your end behavior? And are you using your multiplicities accurately? Does that make sense? Those are the 3 things I'm looking for. Okay? So I'm going to bounce. Now, I don't know how low that goes, but I know it has to come back up to that 0, doesn't it? Does that make sense? You guys get what I mean by bouncing? He was negative and he stayed negative. He didn't cross over to be a positive number. Yes? Okay? All right, coming here at 4. That'd be this guy. What's his multiplicity, even or odd? Odd, because it's raised to the power of 1. So therefore, if it is an odd multiplicity, what did we just say happens at that 0? We should cross. So therefore, we're at negative, and we should be going to the positive. Now, once again, do I care how high it goes? No. All right. So using our end behavior here, it says that we should be bouncing. Should we? Why? Looking up here, what's our power? 2, so that is an even power, so therefore should we be bouncing? Does it have the end behavior that we needed? Does it have the multiplicities accurately on every 0 we have? Meaning, if it's even, is it bouncing? Yes. If it's odd, is it crossing? Yes. Are we using all the zeros that are capable there? We have them. Okay? That is our goal today, is to use this type of information to do so. Now, what we have today, though, is sometimes you're going to have to factor them to go ahead and find it. So let's do this guy. All right. Oh, sorry. I want to make them a cube. All right. So our end all be all goal of this is to graph this with the calculator. Okay? So what are the things we're going to need to know? End behavior. Do I have to do anything to find that right now? No, it's telling us right there we can figure it out, right? First off, we want to know the degree. What's the degree? 3. Leading coefficient, 4, which means that is positive, so therefore we have this end behavior. Check mark number 1, we have the end behavior we're needing, right? Is everybody with me on that? Yes, ma'am. No problem. So just to understand what's the difference between this one and the last one. Last one was in factored form or linear pairs, right? This one's still in standard form. So we're going to have to make him into factored form, okay? My question to you guys is, so notice we have our degree and we have our leading coefficient. Do we have our zeros yet? No, that's what we're going to need to do now. Anybody want to help me figure out what's my first step of finding the zeros? Pull out a 4x. I pull out a 4x because they all have a 4x in common. You guys agree with that? Okay. So I'm going to pull out a 4x. What's left over after I pull out a 4x? Okay. Now, can we quick factor him? What's the factors of -6 to give me to be 1? What needs the negative though? -3 and a +2. Do you guys agree with that? So I have 4x. I can quick do this as x minus 3, x plus 2. I could go through the whole factoring process if I needed to though, right? Once again, we spent a few days at the beginning doing so, right? Okay, so what are my zeros? 3 and -2. That's only 2 zeros. How many zeros do I need? 3 of them. So 3 is here. That's awesome. 2 is here. And 0, right, Jenna? Because this guy gives me 0, doesn't he? A lot of people forget him. But he's 0. Yes, sir. Oh, thank you about that. Okay. What are the multiplicities of each of these zeros? How about 0? What's the multiplicity? What's the power on the x? 1, right? 1, 1. So at every one of these zeros, what should we be doing when we graph it? We should be crossing or going through, correct? Okay, so I'm going to start over here. I'm going to plot my zeros first. 0, 3, -2. Okay. I start with my end behavior. Noticing, once again, this is a positive leading coefficient, right, of an x cubed. So I should be starting down as I'm coming from negative infinity. Do you guys agree with that? Does everybody understand how that happens? Because that's, like I said, end behavior is so important. It's a very simple concept, but it's a big deal. Because if you don't know your end behaviors, you're going to start wrong. Okie dokie smoky. So I start down. I come up to my first 0. Should I cross or bounce? Cross. Cross. Do I have the end behavior that is needed for this graph? Did my crossing and bouncing dictate to get to exactly what I needed it to be? It did. Notice it does end up like such, doesn't it? Now notice, what if I accidentally messed up? Using those same zeros, I had -2, I believe. 0 and 3. Let's say I messed up by chance. Okay, I start my end behavior correctly. Oh, I believe it bounces. Then I get the other 2 right. Did I end up with the end behavior I needed for x cubed? No. So if you mess up, it's not going to give you the correct end behavior. Does that make sense? Okay, unless you mess up horribly each time. Yes. It only can cross through the zeros at those times because, once again, After that, it's never going to cross the other time because those are the only place that it equaled 0, correct? So it can't cross any other time because that's what's representing the zeros. This is where the graph is touching the x-axis or crossing the x-axis, right? Does that make sense? Guys, that's a good question. Can we cross the graph anywhere else? No, or there'd be another 0, wouldn't there? Now, do all of my zeros have to be nice integer numbers? Could they come out to be like, for example, what if the equation was x squared minus 3? The zeros of that is square root of 3 and negative square root of 3. Those aren't nice integers, but are they still values that make that graph 0? So you might have to find those via quadratic formula or factoring, either or. Does that make sense to everybody? I believe that everything we do today will be nice numbers. Okay? Any questions so far? Pretty self-explanatory. Well, not self-explanatory, but something we can do. Okay, we talked about relative mins and maxes. So, for example, like I'm not graphing that last graph accurately ever. Once again, it was -2, 0, 3, which we had. Am I really graphing that? Is that the best graph that it is? This is a good test. Sure. Notice how high do I know this goes? I don't. I just made him come back down. Okay, but that is called a relative maximum, isn't it? Is this a maximum value of our graph? Is this high point? What's the highest we ever go? Infinity. Is this the lowest low point that I've ever had? No, because negative infinity would be, right? So hence why they call them relative mins and maxes, because I don't necessarily have an exact max or an exact min, because once again, they're going on forever, right? Does that make sense to everybody? How do we find that max and min point? Via our calculator, we're going to go ahead and plug it in, find the max, and we're going to plug it in and find the min. Let's hurry and quickly graph that graph. What was it again? X cubed, 4x cubed, minus 4x squared, minus 24x. Is that correct? Is that what I started with? Okay, go ahead and quickly put that in your machine. Let's see what we got. No machine, huh? Is it off the screen of -10 to 10? Yeah, so is my graph very accurate? No, and I don't give a rat's patootie. Really, I don't. But if they're asking you to find it, you might have to adjust your window, correct? You'll notice that as if you actually did it, probably goes out of your window. If you go to the -10 to 10, it probably goes like this. Whoop, and then it'll come down like whoop. Whoop, should be through the 0, but you guys get that. And it'll come down and go whoop. See, I don't have my highs and lows, so therefore I adjust my window to make sure it's happening. Everything kosher? The rabbi blessed it and everything? I believe that's what makes things kosher. That could be offensive, I guess. We live in a world that everybody takes offense to everything. Wasn't trying to offend anyone. I've had kosher salt. I don't know the difference between one salt and the other salt. But bigger? Is it kosher because it's kosher? Meaning blessed by a rabbi? Or is it just because it's bigger salt? Okay. You know what I mean, though. Okay, do I need to go over how to find the high point and the low point, or is that something you guys, since we kind of did that last time? Right? Okay. Any questions there on finding highs and lows? I might want to do one of these Yahoo. Okay. How do we find the zeros of this one without using, by the way, we can find the zeros. I can find zeros using your calculator, you think. Same area that you found the highs and the lows. If you hit second calculate, everybody hit second calculate with me. And see how it says 0? You can find zeros using your graph just as well. But once again, on your test day, am I going to let you use your calculator the whole time? No, because I want to see if you guys know how to find the zeros, factoring, and so forth. Okay? Okay, really quickly, here we go. Let's graph this son of a monkey's uncle. Son of a monkey. Okay? How do I graph a 4-term polynomial that is x cubed? The only way I do know how to find them right now is by factor by grouping. Okay? So, we're going to group the front two, if you recall. We're going to group the back two. What does the front guys have in common? X squared. What's left over? 4x minus 5. What do the back guys have in common? I'm left with okay. Yes? Rachel? No, Williams. Sydney. Sydney? Got it on the second shot. I apologize. You're a little bit yawning. Is it really? Are you tired? What time did you wake up? Why? Bedtime's at 8:30. At my house, we all really go to bed at 8:30. Our kids, they have to go to bed at 8:30. Nope. I'm one of those guys that the head hits the pillow and I'm down. Okay, here we go. But I do get here. I'm here at 6. So I pull out the 4x minus 5. I'm left with x squared minus 3. No! I don't know what that meant. Is that my 5-minute mark? 10-minute mark? All right, ladies and gentlemen, what's the zeros of this polynomial? This one's pretty simple. It is add 5, divide by 4. Does everybody understand how he's 5/4? What is his multiplicity? 1, so therefore at that 0 I will be crossing, correct? Okay, what's this? Square root of 3 because I set this equal to 0. Remember it's plus or minus root 3. So notice each of those actually have a multiplicity of 1 as well. Because if I wrote it as a product of linear factors, remember that from the other day? Product of linear factors, I would write this as x minus root 3, and this guy would be x plus root 3. You guys remember that? And they would all have multiplicities of 1, because it's x cubed, and I can't take x cubed, have my multiplicities, and they all have to add up to be 3, because 1 plus 1 plus 1 is 3, that's the highest I can be. That's actually the fundamental theorem of algebra, is that whatever degree of a polynomial, that tells you how many zeros you can have at most. Okay, with me? Now, what if this was x squared plus 3? Those would be imaginary things, wouldn't they? So therefore, would I graph imaginary solutions? No. I would just graph this 1. Okay? Does that make sense? Okay. So let's go ahead and graph this though. I'm going to sneak down. Can somebody tell me roughly what root 3 is? I know it's less than 2. How do I know it's less than 2? 1.7 something? Okay. How do I know it's less than 2? Square root of 4 is 2, and square root of 4 is greater than square root of 3, right? Okay, here we go. So 5/4 is like 1.25, and then you said 1.73 as well, something like that. Then we have negative 1.73. So those are our 3 spots that we hit the x-axis at, right? Good? Okay. Now, looking at our end behavior. What is it? It's x cubed. So first off, x cubed is boom, right? What was our leading coefficient? Positive. Is it always going to be positive? I'm sorry, I keep giving you examples that are positive. Is it always going to be positive? No, but it is in our case, isn't it? Okay, and because each of these are all multiplicities of 1, at these zeros, am I crossing or am I bouncing? Crossing. Go through your zeros now. Does it have the end behavior that is needed? Does it have crossing at every zero? Take that. Water. Yay. Awesome sauce. Okay. You feeling okay? Sir, yes, sir. The 3 zeros? 1, 2, 3. Where did I get those numbers? 1. And then I solved it. Okay. You guys see that's raised to the 4th power on the end. Okay, what's easy for us to see this time? We can see that it is, first off, all of our zeros are really easy to see, aren't they? Okay. Is our degree as easy to see? It's available. It's there. It's just that we have to do a little work to find him, right? This is 2, 3, because there's a 1 there. 4 plus 4 is 8. So this is x to the 8th, which has the end behavior of going up if my leading coefficient is positive, correct? And I don't know yet, so let's check it out. Okay? Somebody said it's not. Did you say that, Abby? Okay, so right there, what's negative x squared times x? Negative x cubed. Negative x cubed times 4x. Negative 4x to the 4th. What is this guy? He's negative. But I raised him to the 4th power. What's he going to come out to be? He'll come out to be a positive, won't he? So I have a negative 4x to the 4th times 81 x to the 4th, which comes out to be a negative big A number, x to the 8th. Right? But the key thing is that it is negative. So therefore, what does that do to our end behavior? We went up from up to down. Right? Does everybody understand how I found my leading coefficient? I look at the front terms and I look at its multiplicity to see if it'll change anything on it. Because this is already squared with our negative on it, that's why he was negative instead of negative x squared, right? See how there's a difference? So, once again, degree is 8. Our leading coefficient is less than 0. What are our zeros? Emily, give me one of the zeros.
Zero.
Zero. Look at zero. Paige, that's what it is. Paige, give me another zero. What about this guy? 3, right? Lilo. Tell me your name again. Nicole. Nicole, what's the zero? -7/4. Because I got to divide, subtract the 7, then divide by 4. Is everybody with me on that? So I have 0, 3, -7/4, which is right there. And what's the other 0? 2/3. I think Oscar, you said that, right? Oh, Abby, you find, I'm sorry. Saying your name right though. 2/3. Here we go. 2/3 is right here. Okay. So, starting with our end behavior, which is looking like such, correct? We're going to start down, and we better hope that we end down, don't we? Are you okay, bud? Help? More welcome. I'm here to help you. I know Abdi could help you, but I'm the man. Because I subtract the 2 and then divide by -2. Does that make sense? So, I'm starting down. Here we go. Then we come up to this. Remember, this 0 was -7/4. What's our multiplicity on him? 1, which is odd. Therefore, we are going to cross. We come over to 0. His multiplicity is what, Noah? 2. So therefore, I should bounce or cross. Bounce. The 2/3. Bounce or cross. Bounce. 3. Cross. Do I end up with the end behavior I'm needing? Pretty interesting, isn't it? It does have 8 zeros. Ready? 1, 2. 3, 4, 5, 6, 7, 8. So remember, multiplicity says I am using this 0 4 times to add up to be this. Does that make sense? Hence why, once again, how many turning points does this have? 1, 2, 3, 4, 5, right? How many could it have? 7. But the reason why it doesn't is because we have 2 places that the zeros are being used as multiplicities that are evening it down. So it's taking up. So there's a couple that are taking them up. Okay, how do we feel? Not too bad for the day. I just want to make sure I covered everything. You get out the 1-3 stuff for me. Give me 1 second. I'll explain that. Will you start passing them out for me? Okay, really quick. Isabel asked a great question. Why does it matter what your leading coefficient is? What does that tell for us? It helps us with our end behavior. We know our end behavior is either up or down. How do I know I was down though? Because it ended up being a leading coefficient. So that made me go down instead of up. Make sense? Okay, great question. Great question.